Joining me now is astrophysicist and cosmologist at ANU, Brad Tucker, our resident space expert for Space Watch, as we have unofficially called this segment.
You're going to watch space, otherwise it creeps up on you.
You watch space so that we don't have to. We like what you have to add. Now, we're talking about the sun, first of all, and the sun's corona. That's the atmosphere of the sun.
Yep.
We've got a bit of a hint as to why. Now, I found this extraordinary. The atmosphere of the sun is hundreds of times hotter than the sun itself.
Yeah, exactly. It's about 4 million degrees Celsius, where the surface is only 6,000 degrees. You know, still hot, but we're talking about dramatically different. And so NASA has built this, the Solar Parker probe, to go essentially to, as close as it can to the outer edges, the corona of the sun. So the first batch of data has just come back from this. So it's currently orbiting about 24 million kilometers from the sun.
Right, because that makes it look like it's a lot closer.
It is obviously some animations here, but I mean, it is creeping up where it's going to be withstanding 1,600 degrees Celsius temperatures because of this. It has this giant heat shield to protect it from the blasting of the sun. And because it can't look directly at the sun because of the heat, it's kind of looking off to the side and seeing what the sun is producing.
So it looks at the atmosphere kind of in these flares.
Exactly, and the flares coming, because one of the big things is the sun actually has a wind that blows off of it, and this wind hits the Earth, slams into it, and creates things like the aurora. But the wind, if it's charged enough and hits enough the right way, it actually can cause satellite interference. So what we call solar weather is a big deal of understanding how we communicate here on Earth, because it's a real challenge, actually.
So that graphic before, I hope it comes up again, it made it look like the sun was blowing dust.
It is, exactly.
At the Earth, and what our atmosphere protects that.
Yeah, so we have this, so most of it's this magnetic bubble we have, right, in the North and South Pole. So the magnetic bubble protects us from getting radiation to the surface, but it also is the reason we have aurora. But, you know, you can imagine if you get a really strong wind, you start to actually blow that in, and the stronger the wind, the more likely you're to get that radiation to the surface. Yeah, here. So there is dust and particles blowing off this, slamming into the Earth. And keeping in mind, we're protected, but the satellites end up outside that bubble, and they can actually disrupt them or break them.
And so 1,600 degrees is what this
probe is able to be built in. Right. And so the big question is, where does this wind, where does this stuff originate from? And it looks like there's a hole that opens up in the corona and kind of has these jet streams essentially shooting out of the sun's surface, blasting us into Earth.
It still seems weird because it's shooting out of the surface, but the surface isn't as hot as the corona.
Yeah, this is another big question we really don't know.
The heat comes from maybe right inside the sun, so it's hotter there, cooler on the surface.
And then somehow there's some sort of convection, there's some sort of process going on. So this is why this probe's built to boldly go where no probe has gone before,
which is still a long way away.
Yeah.
Fair enough. We've also got a Neptune-like planet that's been discovered around a white dwarf. So it's described as unique or somewhat unique because it's now too close to the star. So the gravities of the star are sucking off the atmosphere of the planet. So this is happening here on this.
That's right. So a white dwarf is something like our sun will be in billions of years. Now, it's a sun that has essentially erupted, and we've known that if a white dwarf gets too close to a star, the gravity of it can actually suck off the star and eventually explode. We've known this for quite a while. In fact, this is something I discovered here, in fact, this system.
So the dwarf explodes, not the star.
That's right, exactly. But the question is, what happens if a planet gets too close? And so it appears if you get a planet close enough, because it still actually has a lot of gravity, the actual atmosphere of this planet can be sucked off and thrown around. So, you know, we know that when our sun expands, it'll probably swallow up some of the inner planets. But it appears that even places like Jupiter and Saturn, because of the gravity, it will strip off its atmosphere and actually kill it as well. So it's a really glimpse, of kind of a horrifying glimpse also ultimately into what will happen to our solar system and everything in it.
So Mercury would be first.
So Mercury's long gone. So as the sun will expand, it will swallow up Mercury, and then it'll swallow up...
When you say swallow up, is it going to explode? If we were somehow here on Earth when it happened, what would we see? Would it be
so literally the sun will just slowly grow. So it's kind of like the sun's getting closer and closer to us, and eventually the inside of the sun, or Mercury, will be inside the sun, and then Venus
just melts it and
breaks it down, essentially. So as the sun's surface grows, our oceans will boil away, will heat up, and eventually will almost melt to a certain point. But because it still has all this gravity, it will get and expand. It will actually pull the planets closer in, and then gravity will suck off the atmosphere of those planets, so nothing is safe.
All right, so get all your good living in the next few billion years. NASA's OSIRIS-REx, meanwhile, has been tracking Bennu, I think that's how you say it, for a while, and something interesting has finally happened.
Yeah, so Bennu is one of these asteroids. Now, the reason we're interested in these types of asteroids is instead of one chunk, it appears to be a bunch of whole loosely collected rubble. So it's kind of like a dirty snowball.
It looked like a chunk, though.
Yeah.
Is that because this is just a...
No, it's actually because we think that a bunch of it has just been clumped together, and that's all that's left.
So now it's a clump, but it all came together from other stuff.
Yeah, exactly. Right. So instead of a really solid thing, it's like a loosely held pile of rubble. So this probe has left the Earth and has actually reached the asteroid. And so one of the big questions is, are they actually collections of pile? And if they're collections of pile of rubble, can they break apart? Because one of the big questions is, can we stop one of these things if it's headed towards the Earth? And so as OSIRIS-REx approached the asteroid, it actually saw stuff breaking off of it, like it's actually fracturing or fissuring. So jets of rock and stuff were shooting off this asteroid.
So if something was coming towards us and we wanted to just go, all right, we'll ping this here and it'll...
That's right.
There. The problem is if it breaks up, it
still comes back to Earth, right? You know, it's a classic Armageddon. One big chunk and two large chunks still hit the Earth, and it's not great.
Smaller the better, though, right?
It is. Smaller the better, and if you can make it small enough, it can burn up more than
what do we actually find out here, just to be prepared for more?
Well, so the big question is what this probe's going to do is land actually on the surface and drill and suction down into the surface, not only see what the material's made up of, but potential targets for future mining, but also can we break it apart, and what can we do? Because missions are being planned to try and divert these things that may hit the Earth.
Brad Tugger, as always, thank you.